Looks good.
Great. Okay, this is Pete number 2 on the StreamStats team. Pete Steves in this case. I'm going to be, as Greg just said, presenting for both Elena Spetzel and myself today, and Elena's not able to present, so I am happy to take the lead on that. So this project is one of those ecosystems of services that Pete mentioned. I think every one of these could have a full-length talk, the ones that Pete gave or just covered briefly on. So I'll dip into it a little deeper with this one, which is integrating stormwater drainage into the U.S. Geological Survey StreamStats application. In this particular case, the Mystic River Basin Watershed. I have a base map that shows you just where that is in the Boston area. It's coming up, but yeah, just hold tight with that. And this is a USGS Urban Waters Federal Partnership joint project in cooperation with EPA Region 1. So in this presentation, there'll be a demonstration on how StreamStats works in the Mystic River Basin, particularly on stormwater drainage. It's quite a development with StreamStats tools that I'm very excited about. And then we'll discuss the processing methods that go into this that are pretty unique compared to the traditional way we've processed data in StreamStats over these many years. And finally, I'll mention some benefits for urban stormwater applications. So for lack of a better term, again, traditional StreamStats, these are in natural flowing areas on the left. We typically just work with surface waters, but in these urban areas on the right, we take into account, well, they're depicted in orange here, which are pipelines in orange, orange linear lines, and then the inlets that go into them, which are the stormwater grates or the catch basins. It's also allows for inflow into the storm drains from surface flow as well. So you can see in this snapshot area in a part of the Mystic Basin that there's a lot more detail, not only by adding the storm drains, but in the stream networks too, because this is all LiDAR derived at 1 meter resolution. It's the most dense resolution data we've processed for StreamStats yet. It isn't the first storm drain project for StreamStats. The first one was in St. Louis, Missouri, but it is enhancing the resolution even from that, which was a 2 meter resolution. This is 1 meter. This one's also watershed oriented. So as with many StreamStats projects, just building on what's been done in the past. I point out this slide, it's similar to something Pete already has shown, but just to point out that we're focused primarily in this project with getting accurate basin delineations from storm drains and from surface flow, as well as getting basin characteristics that are important in urban areas, such as impervious flows, drainage areas, and things like percent industrial and commercial and the like. So, and I'm sure we'll continue to do. One thing we have not focused on at this stage with this project is estimating flow statistics in urban areas, particularly in pipes. Those concepts are still being kind of addressed and how we're going to approach those going into the future. But we do have another project on board now with the StreamStats, which is Washington, D.C., which does have the intention of taking that third principal functionality into account, which is the estimation of flow statistics. So this will get us well on the way there, and hopefully we'll be able to kind of collaborate with the DC effort to move into the flow statistics at another stage of this project. Okay, here's that pilot map I promised. So this is an area just north of Boston. It's in a very urban and very historical area. Canals have been built here back in the 1830s, diverting water that still has an effect on flow in this area. All sorts of other historical aspects to the region, including the storm drain network, and numerous municipalities that this watershed overlaps. And we've had to collect data from each and every one of these municipalities, and we've had a great collaboration with the state in that regard, MassGIS, to help us kind of bridge the difference between a federal agency's efforts and the focus of municipalities. The state is a great bridge to kind of try to collaborate and work with, and that has played out with MassGIS in this case, and MassDEP as well. Okay, at this stage, I am going to run a video. So I need to include the sound, and here we go.
We'll start off in StreamStats. We're already zoomed in here to the Aberjona, which is highlighted by a hatchet area around it, which helps you focus on the study area itself. You'll see there's nothing really to show here except a base map at this moment. But as you zoom in, you'll be able to see more details in the base map. And then finally, you get to a level where you can see all the detail that we have associated with this project. Right off, you're going to see three different types of features. You see blue lines, which represent the surface flow. You'll see orange squares, which represent the catch basins, the storm grates that allow flow to enter the underground storm drains, and then the storm drains themselves, which are also in orange and represented as linear features. I'm going to start by, and I would recommend to others do this too. There's an additional layer that we have by default for most StreamStats projects. It's called the stream grid. It's not all that helpful here. In fact, it's in some ways it's a bit confusing. So I typically turn that off. You can still see we have surface flow represented. It's just kind of a duplicate of the surface flow. Okay, so let's do a few examples. What I'd like to do is look at a few different areas and then do some representation of delineations from a storm drain location as well as from a surface flow location. So here is an area. We'll start off. Let's see. I prefer to start off with a storm drain location, just kind of get right at that initially. So here's a long storm drain in the northern portion of the Aberjona up by the North Woburn Wilmington border. And you can see almost all the drainage area upstream of this major storm drain is storm drains. There's no real surface flow to speak of in this area. So we're going to click the storm drain, and you use the delineate tool here on the left. And you select the storm drain. this is the delineation that you get from that click point. So what's happening is you don't get an immediate contributing area around that click point because you've asked the process to use the storm drain itself underground. All these catch basins are where the storm drain is daylighted, and those are what give you the unique drainage area in comparison to a natural flow drainage area for the contributing area to that storm drain. You can see most of this is commercial area. Some of it is rooftops, very commercial area, and that's the contributing area that we've determined from the data given to us by the towns of Woburn and Wilmington in this area. So that gives you kind of an idea on how the storm drains functionality works. I'd like to also show how this works in tandem with with the surface water. So here's an area over by Reading, the Woburn-Reading line. The headwaters of the Aberjona is in this area, and if we want to go on to another delineation, you could say Clear Basin, and now we're ready to delineate again. And what I'm going to do here is I'm going to delineate a drainage point downstream of this railroad crossing on a stream flow. You can see we have a culvert mapped underneath. The culverts are also part of the storm drain data set. They're uniquely attributed, but this culvert makes its way under the railroad. Keep an eye on that. After the delineation, I'll point out a few things. So I'm going to go ahead, delineate surface flow from this little tributary to the Aberjona, contributes flow from this railroad culvert crossing. This, I wanted to point out a few things happening here. The contributing area shows a delineation that grabs flow on the other side of this railroad, and the railroad is actually used as a basin boundary for a good stretch. And then you'll see that some of the flow upstream is surface flow, but much of it is also catch basin flow from storm drains. And you can also see these disconnected pieces of the basin. This is what you're going to see in urban areas as opposed to natural flowing areas where the delineated watershed is always one polygon. But in these cases, what you're going to see is disconnected pieces because the storm drain that makes up this flow here doesn't have any catch basins in this area. So this area actually contributes to other areas. I'm thinking this flow, this culvert that goes under the railroad here, is probably the contributing area for this stretch of this neighborhood. And again, another point here, that's a disconnect. So these are the types of unique delineations that you see with urban storm drain delineations.
Okay. So that's the video portion of the presentation. Move on to the next slide. Before I move on, just a couple of comments related to that video. I mentioned the Aberjona basin. So this Mystic River Basin is made up of two 12-digit hydrologic units, and the upper unit is the Aberjona, which has been completed. The lower unit we refer to as the Mystic proper, which we're in the process of processing now, but the upper Aberjona has been completed, and we have it up on our development site, which is what you were seeing there. It's not yet on our production site because this data is yet to be published. Just one other note, one thing that we have come to the conclusion on is this type of functionality in storm drains would work very similarly in karst areas. So we're looking into incorporating karst area related projects, let's say, or enhancing some of the states that already have karst mapping with this type of functionality. Just a few more slides now. So the high resolution elevation and hydrography data are used with municipal data to build a geometric network. I mentioned the municipalities. There's one other entity that is important to this audience, and that is transportation DOTs, which have their own jurisdiction with storm drain mapping. So that's another entity. We've been talking with the Mass DOT to try to collect storm drain mapping data from them as well. And you can see this is the Route 128 that cuts through Woburn, and all the mapping that has to play out in this area in conjunction with the city of Woburn, which has the storm drain data on to the north and south of Route 128, but not on 128 itself, other than maybe the catch basins in some cases. So, and on the right side here, so you can see the imagery on the left, which helps us in the process of pulling this data together, and in a lot of cases enhancing it, making it better. We receive this data in various levels of completeness and quality from the towns who are still in the process of developing in themselves. So we have to go forward and make some decisions on connectivity ourselves. And one thing that really helps us is the LiDAR data, and being able to just see depressions and just the way that the landscape flows, and just how the storm drains would work in conjunction with that. Again, more base maps. These are base maps that we use. We use topographic base maps. We use LiDAR. We use imagery, various other base maps that help us to pull this all together to make a framework to be able to do this sort of thing. Oh, this is a slide that shows the upper. This is the Aberjona with the green finished data, and we're moving into. We've actually made progress from this slide. Arlington, well on our way to finishing that. Winchester's done. So we're making our way down to Boston Harbor, and then you'll be able to delineate a watershed from the Mystic River itself by the harbor and get the entire contributing area at this resolution. So finally, just ways that we've been thinking about enhancing StreamStats with urban infrastructure data. It can support efforts to do some mitigation of flooding, mapping culverts, which is becoming a really big deal now, with elevation-derived hydro projects for the National Hydrography Data Set, as well as other projects. Illicit discharges, meeting permit requirements, and to address water quality concerns. So thank you. That's it. Great.